Hi, and welcome to this video tutorial series where I'll be showing you guys some cool new features on the analog to digital converter with computation featured in the new PIC18F Q10 Product Family. In this second video, I'll be using some joysticks to show you how to sample multiple ADC channels and also how to graph that using the Power Debugger and the Data Visualizer tool. So let's get started. Alright, so we have our Curiosity HPC development board set up again, and this time we'll be using these joysticks as our analog sensors. Now these joysticks have two axes, so we need to read both of those, and in total we will be using 4 analog channels. So we also connected the TX port from the EUSART on the device over to the CDC virtual COM port on the Power Debugger. And then we also have some voltage and ground reference going into G, ND, and ref. Then, like last time, I've opened up a brand new project in MPLAB X, and we're still using the same device, and we're using the XE8 Pro compiler. So we're looking at the system module in MCC, and since this time we'll be sampling 4 different channels, we want the clock to go a little bit faster than before. So we'll still be using the high frequency internal oscillator, but we will remove this clock divider. And then we can go ahead and add the ADC from the peripheral list. Now this time we need to think a little bit about this TAD. This TAD here is the time that it takes for the ADC to make 1 bit conversion. And it has a minimum value in the datasheet, which is 1 microsecond. And you can see here, this is about half that. And this one is dependent on the system oscillator, which we just changed, so that makes sense. And to fix this, we can go ahead and change the prescaler going into the ADC. So we'll double that and get 1 microsecond. And then also this notification that we just had there was removed. Then we should put on some acquisition count, so that this is the time that the ADC lets the sample and hold capacitor charge before converting. And since the oscillator is 4 times faster, we need 4 times as many counts as we did before. So before we had 5 counts for the 5 microseconds. This time we need to multiply that by 4, and then we get 20. So 20 counts is 5 microseconds. Then we'll go ahead and add the EUSART. And like before, we need to enable a transmit in order for us to transmit the data. And then since we have more data to transmit, we'll increase the baud rate to 19200. Then we can go over to this pin module and add the joysticks. The joysticks are connected to pin RB0, 1, 2, and 3. So we'll add those here. We can find port B and then those pins 0 to 3 here. Then we have the analog input row over here. Just add those 4. And then here we can start seeing the reason why we want to change to a custom name, because we would like to reference this in the code and we want it to be readable. So we will change this to left X, left Y, right X, and right Y. And then we can go ahead and generate. Alright, so now that that's been generated, we can exit MCC and open up our project and our main file. First of all, we like a way for us to present our variable that we want to store these ADC results in. We want to present that in a good way, so we will make a data type, so type def, and then we'll use a struct. And then we'll fill that with some 16-bit unsigned integers to store the results in, and we'll call those left X, left Y, right Y, and right X. And then we can call this type joysticks _t. Alright, so now we need to create a variable based on this data type.
So we will use joysticks underscore t, and then we'll make a new variable called positions, because this includes the positions of those different channels. And then, like we did in the last video with that floating point, we needed a byte pointer in order for us to be able to send each byte by itself over the USART. So we'll do the exact same thing here. So 8-bit pointer, and we'll call that plus pointer. And then we will add our variable. All right. And then also, if you remember in the last video, we also, because we're using a for loop to iterate through all of those bytes, we also need that one iterator, so an 8-bit iterator called I. Now we can start feeding some data into our variable. So we will call positions.left x first equals 2, and then we'll use our function that MCC has generated for us, and then control spacebar to get some suggestions, and then we'll add our channel. Then we'll do the same for the other channels as well. All right, and there we go. And now, since we have 4 different channels, we would like to have maybe different signals for those channels. So one channel might be 5 volts, and then you might go over to reading the other channel, like left Y after left X, and then that might be 0 volts. So in those cases, it may be that the sample and hold capacitor hasn't discharged enough for that result to be valid. So what we want to do then is we want to make a full conversion that we don't store. We want to make that conversion to the ground channel. So we'll do that. So that is channel VSS. So what happens then is that the sample and hold capacitor is allowed to be fully discharged before making a new conversion. So this will ensure correct results all the way. All right, so now we have data coming into our variable, and now we can go ahead and transmit these over the USART. And like before, we need to go ahead and revisit the Data Visualizer User's Guide. So we'll open that up. And then we'll find the stream format again. And we're reminded that we need a start frame and an end frame. And these can be anything as long as they're bitwise opposite. So we'll go into our code and define those. So start frame, then we can have that as 0x33, for example. And then, end frame. And then for simplicity again, we can do that as the opposite of the start frame. And now we can send that over the USART. And then also the end frame. And then we can start writing out our data, so we still need that for loop like in the last video. So for I equals to 0, and then we're going to repeat that as long as I is smaller than the size of our new data type, so joysticks underscore t. Oops. There we go. And then we'll iterate. And then inside this for loop, we can now use our byte pointer, so pause. We're going to be using the USART function first, of course, to send that. And then we can use our byte pointer, so pause pointer. And then we'll iterate through that using this iterator. And there we go. And then one thing we also need to do, like in the last video, we need to add a small delay to make sure that everything is synchronized so that the data visualizer won't be confused. So we'll just make a 10 millisecond delay there. And then we can go ahead and program. All right, so now that that's been programmed, we can go ahead and look at the configuration file like in the last video. So basically just to tell the data visualizer how it's going to present our signals in the GUI. And this time, since we have multiple signals, this makes more sense than before. So here we go. Here's an example configuration for multiple signals. And I have created a file that looks almost like that. So we're still using unsigned short. We have 2-byte result there. So we're using D in front here as the tag, and then we have the matrix positions of the GUI and then the names for them. So just save that and close it down, and then open up the data visualizer. And then we can close down the DJI control panel like before and open up the serial port. And then we need to make sure that the power debugger is selected, and then change the baud rate to 19200. And then we can connect. We'll check off hexadecimal values, and here we can see that it looks like our package is correct. So we can close that down and open up the data stream protocol. We'll browse for that new file that we created and then load that. And there we can see that we get the left channels on the left hand side and then the right channels on the right hand side. So this looks really pretty. So that's the reason why we do this configuration file right there. Then we can open up a graph. And then not to forget, we need to add, of course, this plug from the serial port, connecting the data into those different signals that we have there. Then we can add these channels into new plots. So 1 new plot per channel. And here you can see those signals coming in there. And then if I start wiggling my joysticks, we can clearly see that that is being read live on the graph. And as you can see, this is something that you can use to make a gaming interface. And these joysticks are exactly the same as are being used in popular gaming consoles.